I have a problem for you. This is a scalene triangle, and I want to use an angle bisector on the angle that's opposite the base, the angle at the top of the triangle. Just as a reminder, an angle bisector is a line that cuts an angle exactly in half. Now, if I use an angle bisector on the top angle and make it long enough so that it intersects with the base, the angle at the top is bisected, and the angle bisector intersects with the base. I'm going to make a statement that because this triangle is scalene, meaning that all three of the angles are unique, the angle bisector can never be perpendicular to the base. Well, can you prove that? Would you know how to go about proving it? You might argue that it's quite obvious that the bisector is not perpendicular, but this drawing is not to scale, and anyway, how would you prove it for all scalene triangles? Well, that's what we're here to do. Before bisecting the angle, its value was A, and bisecting the angle results in two angles, and their values will be A over 2. And because the line passes right through the triangle, this results in it being divided into two triangles, each with the top angle value of A over 2, and each triangle having one of the base angles of the original triangle. To see these triangles more clearly, I'll change the color of the bisector. The bisector, because it intersected with the base, created two new base angles, one belonging to the triangle on the left and the other belonging to the triangle on the right. I'm going to label those angles X and Y. We're going to show that the bisector is not perpendicular by using the angles X and Y and the fact that the triangle is scalene. First, we have to remember what it means to be perpendicular. Here are two intersecting lines that are perpendicular. The reason why they are perpendicular is that they intersect at 90 degrees. And also, because adjacent angles are distributed across a straight line, the sum of adjacent angles must be 180 degrees. So if one side of the perpendicular line is 90 degrees, the other side of the perpendicular line must also be 90 degrees. So if the two lines are perpendicular, the adjacent angles must have exactly the same value. Now if you look at the angles X and Y, they are adjacent and they are on an intersect of two lines. And they are distributed across 180 degrees. So their sum value is 180 degrees. If X and Y have the same value, then they must both be 90 degree angles, which would mean that the intersecting lines, the base of the triangle and the angle bisector, are perpendicular. If on the other hand they're not equal, then neither of them are 90 degrees, which means that the intersection between the base of the triangle and the angle bisector cannot be perpendicular. I'm going to show you why they are not equal, which will confirm the initial claim that the bisector can never be perpendicular to the base. Now let's think about the relationship between the base angles C and B of this triangle. The triangle is scalene, and that means that the angles in the triangle are unique, which means that no two angles are the same. So that has to mean that the angle C is not equal to the angle B. Now if you consider the sum C minus B, well, if C and B were the same thing, that would be 0. But C does not equal B, so C minus B cannot be equal to 0. Now let's go back to the triangle divided by the angle bisector. We have not altered the angles, so the relationship between C and B stands. C minus B is not equal to 0. Now let's imagine for a moment that this line was perpendicular, and that would mean that X would be equal to Y. Now because they have the same value, X minus Y must equal to 0, and if we flip this around it wouldn't make any difference because they're the same value, so Y minus X would also be equal to 0. Now if we consider that the top angle of both triangles is the same value, the sum of base angles in both triangles must be the same. That is 180 degrees minus A over 2. So C plus X must be 180 degrees minus A over 2, and Y plus B must be equal to 180 degrees minus A over 2. And that must mean that C plus X is equal to Y plus B. Let's subtract X from both sides. The X and the minus X cancel, and then let's subtract B from both sides, and the plus B and the minus B on the right hand side cancel, and that leaves us that C minus B is equal to Y minus X. Now we said that if the angle bisector passing through the base is perpendicular, x is equal to y, and if that's true, then y minus x is equal to 0. Well, in the equation we just found, we have y minus x, so we could replace this y minus x with 0, which would mean that c minus b is equal to 0. And so that means that c must be equal to b. But do you see a problem here? Earlier on, we said that c is not equal to b, and the reason why we know that c cannot be equal to b is because c and b belong to this scalene triangle, and the angles in a scalene triangle are unique, so it's impossible for c to be equal to b in this triangle. Well, if that's true, then c minus b cannot be equal to 0. Now we know that c minus b must be equal to y minus x because we got that by rearranging the values for the base angles in both triangles which were equal to each other. So we have that the left hand side of the equation is equal to the right hand side of the equation, and we know that the left hand side of the equation, c minus b, does not equal 0. So that means the right hand side of the equation, y minus x, is not equal to 0. And if that's true, then x does not equal y, and if x does not equal y, the angle bisector is not perpendicular to the base. In a scalene triangle, the angle bisector that passes through the base is never perpendicular to the base. But we can go further and draw conclusions about other types of triangles where the angle bisector passes through the base by using this equation. Now, if the divided triangle is isosceles or equilateral, because in those triangle types the base angles are equal, c would be equal to b. And if c equals b, then c minus b must be equal to 0. But c minus b is the left-hand side of the equation, and the right-hand side of the equation is equal to the left-hand side of the equation, so that must mean that y minus x must be equal to 0, and if y minus x equals 0, y equals x. And if y and x have the same value, they must be right angles, which means that in an equilateral or isosceles triangle, the angle bisector passing through the base must be perpendicular to the base. And that's the other result that we can get from this. Stay tuned, because in a future video, I'll be using this property of angle bisectors passing through the base of a triangle in order to demonstrate another proof. Well, that's it for now. Thanks for watching.